Today we're going to talk atmospheric pressure. That could be your heading. Go ahead and write down that little bullet there. Atmospheric pressure, the pressure that the atmosphere puts on the ground. Atmospheric pressure is the pressure that the atmosphere puts on the ground. We've mentioned this numerous times, but we have to realize that air molecules have mass. And if we have air molecules stacked on top of us, it's weighing us down. And that is atmospheric pressure. So, atmospheric pressure of air molecules stacked on top of us. If we had no air in the atmosphere, if we were in space, we wouldn't have that pressure stacked on top of us. I would write this down. Gases have mass, they have weight. Pressure is highest at lower elevations, more air molecules pressing down on you. So if you are below sea level, you're going to have more air molecules stacked on top of you than if you're on the top of Mount Everest, because there's less there. If you think of it in terms of water, okay, it's the same thing. If you go to a swimming pool and you sit on the bottom of the pool in the 3 foot, there's water on top of you, and you can feel that weight. Well, if you went to the deep, the 12 foot, and laid at the bottom there, there's more water stacked on top of you, so you're gonna have more pressure on you. Well, the same thing with air. The lower you are, the more air molecules stacked on top of you, the higher the pressure. Now, we don't realize that there's atmospheric pressure because we're used to it. From the instant we are born, we have those air molecules stacked on top of us. So we don't realize it doesn't feel heavy to us or anything like that. Okay, go ahead and write this down. Changes in atmospheric pressure help meteorologists forecast weather. Changes in atmospheric pressure help meteorologists forecast weather. We'll get into this more in the future, but normally high pressure, if they talk about a high pressure system moving in, that usually means we're going to have clear skies, sunny weather. It could still be cold, but it's going to be sunny and clear most of the time. If they talk about a low pressure system moving in, that usually means it's going to be cloudy, rainy, stormy, snowy, whatever. So we usually like when high pressure comes around. I'd also write all of this. Pressure is measured with a barometer. Okay? They might call it the barometric pressure. That's the tool that you use to measure atmospheric pressure. Just like we use a thermometer to measure the temperature, we use a barometer to measure pressure. Now, temperature has some say in the whole pressure thing, okay? Cold air, and write all this below as well, cold air is more dense. Warm air is less dense, okay? What that means is that when air is cold, it's going to basically kind of huddle up. It's going to jam together. Warm things usually expand, okay? Warm air expands, and almost everything warm expands. You might notice that in sidewalks, like every 3 feet, there's a crack, okay? Well, when we pour sidewalk, when we pour concrete, okay, we make those cuts every so many feet, okay, because concrete expands when it's hot and constricts when it's cold. Okay, so if we didn't put that crack in there, in the hot summer when the concrete got hot, it would expand and it would have no room to expand and it would crack. So we put that in there to keep it from cracking. Because warm things expand, cold things contract. On a really cold morning, if your car is sitting outside and let's say it's like 0 degrees out, your tires might look like they're flat or close to being flat. Okay? Well, no air escaped, they didn't get flat, but instead what happened is that air got cold and it constricted, it got smaller. Okay? It shrunk together. Okay? Once you start driving, the air molecules bump into each other, they warm up, and they expand. And if you drove to school, by the time you got to school, your tires would look fine because those air molecules warmed up. So warm things expand, cold things usually constrict. Okay? If you ever get like a ring stuck on your finger and you can't get it off, the easiest way to do that is to get a bucket of ice water or snow outside or whatever and put your hand in that. And your fingers will shrink and you'll be able to get it off easier. So warm air expands, cold air shrinks. And warm air also holds water better, water vapor better. So that's why it's more humid in the summer and the air is drier in the winter, because warm air holds water better than cold air. That is it for the notes.